wasn't annoying. Okay, so hello. My name is Rosemary, and I'm your SI leader, but I'm guessing everyone who is here already knows that. So, just a quick little thing about what SI is, and then how this course goes, and how it's best to prepare, what we're going to be doing together, all that kind of stuff. So I know a lot of you guys already know what SI and tutoring is because you did Orgo 1 here. But in case you're unfamiliar or you didn't take classes here previously, basically SI sessions are like large group tutoring sessions where you guys come in and I will go over the important concepts with you one more time. We'll work on some practice problems. I'll allow you guys to work in groups to facilitate basically the information and kind of keep going over all the important stuff so you have like a place that's less intimidating than lecture to go over this stuff with me and your peers. And it is really helpful in consolidating information and doing a bunch of practice. That being said, I also offer tutoring hours, which are smaller groups. So in these SI sessions, I tend to get between like 20 and 40 people. And sometimes people can get like intimidated because it's a lot, but now we're online, so it's not as scary. If you are more comfortable with like a smaller setting, the tutoring hours are both online and in person. So in person is a little bit different. My in-person hours are Monday morning, and I will give you guys links to all that information so you can make appointments and whatnot. I believe it's only 2 people per session in person. And so, like, it's social distance. There's like cleaning supplies, so we clean off the desk before and after you come, whatever. So if you would like to be in person, that is an option. However, I do also have online hours, and I believe there are 2 other tutors who offer online hours, and it's kind of the same thing as SI, but even more personalized, and there's less people, so it's less intimidating. People are sending comments in the chat, so I am not ignoring you. I will see that. I will answer that. I do see it, but I'm just trying to like think and read at the same time. So if it takes me a second, please don't get upset. If I don't answer you though, eventually send me a little reminder. So all that said about like what SI is and whatnot, just kind of how these sessions will be held. They will be via WebEx. So all the sessions will be recorded and they will be posted on Canvas. Last semester, I had a lot of issues with the videos not posting properly to Canvas and people not being able to watch them. So I will also record them myself as like a backup. And I created a YouTube channel so that I could upload all those videos and everyone could watch them and not have the annoying things that Canvas does. So I will send you guys a link to that as well if you want to watch them on there. I do also have all my SI sessions and everything from last semester uploaded on there. So if anyone wants to look ahead or maybe you didn't understand how I explained something, you want to see how I did it in the past, you can also watch there. So I will send you the link to that in a second. Also, I see a couple more people who just joined in. Hello, if you have any questions, you can ask in the chat and I will get to them as soon as I can. All right, so tutoring sessions will also be recorded, but I'm not sure if I can post them on like for the whole class to see or if it's just sent to the people who were at the tutoring session. That's something I have to double check with my supervisor, so I will let you guys know as soon as I know. All right, so now someone asked, what's the best way to prepare for the class other than reading the textbook, watching lectures, etc.? So, to be completely honest, unless you're like a die-hard textbook person who needs to read the textbook to understand what's going on, I personally would not recommend reading the textbook as your primary source of studying. So the way Orgo 2 is that it's very similar to Orgo 1, but also not really. And let me explain what I mean by that. So in Orgo 1, Dr. St. Germain tends to make the exams very similar to textbook problems. So if you do the textbook problems, you're likely to be successful, right? However, in Orgo 2, Dr. West does use the book kind of, but he also like picks and chooses little topics that he likes. He adds his own stuff to it. And so the textbook will probably be a lot more information than you need. So what I suggest is, first of all, um, you have live lectures. So go to those, either in person or live on Zoom. That's very helpful because you get to interact with him and ask him questions and whatnot. From then, I think you also have pre-recorded past semester lectures that you can also watch. There are lots and lots and lots and lots of hours worth of lectures that you could watch. So I don't necessarily recommend that being your primary like source of study either. What I recommend you do is take the SI handouts and the PowerPoints that he posts and use the SI handout as like an outline almost. So go through his lecture and his PowerPoint and take the information and kind of just fill out the handout and then do some practice problems that are in the handout, which obviously we'll be going over together. And then once you have an idea of the concepts, use the practice problems in his Canvas page as your primary source of studying. Do those practice problems over and over again. Do as many as you possibly can. And that's the best way to learn this stuff, by doing a bunch of practice problems. Prioritize the ones he posts on Canvas over the ones in the textbook, because again, he is not like super by the textbook. But if you do all the ones that he gives you in the set, and in case anyone doesn't know what I'm talking about, on Canvas he has like a practice problem set for each chapter. So it's like anywhere between 20 and 40 questions that go with each chapter. So those are super, super helpful. That's what you should be using to practice. If you do all of those and you do everything that I've given you guys and you still want more practice, then go to the textbook. Okay. And then the other thing someone asked, which kind of goes with what I was talking about, this is not like Orgo 1 where you have to do a certain amount of time to get certain amount of credit, whatever. SI and tutoring are completely the opposite of mandatory. They're completely optional. It's only for your own benefit. You don't have to go to get any kind of credit for class. That being said, SI and tutoring is super helpful, and it has been shown to like raise people's grades. If they go consistently, they tend to do a lot better in the class. But again, you don't have to go. This is just for fun. And yes, I try to make it fun. Sorry guys, it might take a little getting used to, because I know online is kind of sucky. You guys like don't get that personal experience. We can't really like talk and use a whiteboard and whatnot, but I'm gonna try my best to make it as fun and interactive as I possibly can. Okay, so I think I answered all the questions that were in the chat. Does anyone have any questions, comments, or concerns before we get started into like actual Orgo stuff? Also, you can either chat or like type in the chat, or you can unmute and ask your questions. I completely don't mind that. Whatever you guys want to do. It's very chill here. We're all hanging out. We're all friends here. If there's no questions or anything, I'll give you a second to type things out or unmute and ask your question. But I am just going to share the handout so you guys can see it on my screen. Oh, okay. Someone brought up something very important, which I can't believe I forgot. So they asked if I could send you guys my schedule for SI. Yes, I can. I will open that up as well. So I will tell you verbally while I pull up the schedule. My sessions are going to be Mondays at 3 p.m. So right now. Days at 11:30 a.m. So right after lecture. That was a great question. Okay, so someone also asked, any important tips for study methods and time management for Orgo 2 in the summer versus fall and spring? So everything is kind of more fast-paced in the summer, as I'm sure you guys know. There are less weeks in the semester and everything goes by super fast. The biggest thing that I suggest is practice problems. So stay on track with the course. So don't fall super behind. Don't try to cram at the last minute because Orgo is one of those things that is hard to catch up on. And a lot of the things in Orgo builds on itself. So if you miss like 2 or 3 weeks, then it's time for the exam. You have so much to like catch up on. The biggest thing I can also say, like, while staying on track is, again, use the handouts to figure out like what's the most important topic, I guess, because obviously I can't put every single thing that Dr. West is going to say into the handout, but I do put like the most important topics. So like everything he's going to, or the most important things he'll test you on will be on the handout. So if you are able to go through his lectures and take out the most important information and put it into the handout, that'll be super, super good for managing your time. And then using that key conceptual information, you can do a bunch of practice problems. And then for some reason, my schedule is not up on the class website yet, so I will drop it in the chat in a second. Someone asked, do I post completed SI handouts? So, like, kind of like answer sheets? No, but, okay. People get very upset that I don't post this, but what I do to kind of help you guys instead is before the exam, I'll send you guys like a cheat sheet kind of thing. And it'll be like all the most important concepts and the most important examples, and those will all like obviously have answers. And I send that like with the exam review. I honestly don't have time to post completed SI answer sheets, but since we are online, I do fill them out with you guys like in SI. Like I'll project my screen so you guys can all see it, and then I write in answers. So I haven't had anyone complain or have any issues about not being able to get the answers to all the questions. So you guys can email me if you ever have a problem with that, but that's kind of my shortish response to that. Does that sort of kind of make sense? Yes? Okay, cool. I am sending the schedule in the chat right now. Okay, so that is my SI session schedule for anyone who missed it. I will send you guys the flyer once it's made. For some reason, it hasn't been posted yet. So without further ado, let's get started. So again, I'm reading the chat, so I will answer questions as I see them. You can also feel free at any point to unmute and ask questions or make comments or answer questions, whatever. Okay, let's get started. Alrighty, so we are starting with NMR, which is chapter 9, and that's something you guys did in Orgo 1. So yay, a little bit of review. I know some people are like, I have no idea what NMR is. I just heard someone talk about it and then I took the test and I dumped it from my memory. That's okay. I completely get it. That's what I'm here for. So basically, NMR is a type of spectroscopy. Does anyone remember what NMR stands for?
Nuclear magnetic resonance.
I just read yes that someone said to something I asked before, and I thought they responded to my question just now saying yes, and I was like, do you want to tell me? Okay, yes, it stands for nuclear magnetic resonance, and it basically just means that you are going to shoot, oh, someone said that someone spoke, but I did not hear them. So let me make sure. Ah, let me make sure I can hear you guys. Would someone please be my guinea pig and say something?
Hello? Can you hear me?
Hmm, cool. I don't think I can hear you.
Okay.
I love technology. Okay, let's try this again. Can someone please say something?
Hello.
There we go. Now I can hear you. Hello.
Can you hear me?
Yes, I can.
Okay.
Okay. Were you just answering the question or did you have a question or?
I was just answering the question.
Okay, cool. Thank you very much. I appreciate it. And thank you for letting me know that someone was talking. If it ever sounds like I'm ignoring you, that's just because I didn't turn my volume on or something. So let me know if I ignore you by accident. So, NMR is basically a type of spectroscopy that helps us determine certain information about a structure, the structure of a compound. And in NMR, we are essentially going to take molecules in a magnetic field and we're going to hit them with energy, right? And we're going to absorb the frequency when they flip their spin state. That sounds like a lot of gibberish, I'm sure. We'll go into a little bit more of what that means. But essentially, for now, what I want you guys to know is that in order for something to work on an NMR, it has to have spin. And what we measure is the frequency at which we flip the spin state. So I kind of gave away the answer to number 3. The criteria to be NMR active is to have a spin state. We'll talk about that more in a second. But does anyone know what NMR helps us determine? What does it help us find? Yes, that's the perfect answer. So someone said the connectivity of the carbons and the hydrogens. So it tells us about the carbon hydrogen framework and connectivity. Perfect. So does anyone remember what IR is? Or what it tells us?
IR tells the functional groups.
Exactly. So IR tells us about functional groups. So both of these types of spectroscopy are going to tell us about what's going on in the compound. However, NMR is more useful for telling us information specifically about how things are connected versus IR is just telling us what is in the molecule. So whether we have an OH versus an NH versus a carbonyl versus, the alkene, those kind of things. Any questions about the difference between NMR and IR? Okay, cool. So basically, let's talk about spin state a little bit more. So spin state is essentially just the ability of something to have spin. I don't know how to explain that any better. It's basically talking about the magnetism of an electron and whether it's pointing up or down. Dr. West goes into a lot of detail about these kind of things, but it's not super important for what he tests you on. So I'm going to try to stay as surface level as I can about the actual NMR machine. And we're going to talk more about like the chemistry behind it. So in order for something to have spin, the chemistry definition of it is you have to have an odd number of protons and or neutrons. So I'll zoom back out. So I'll repeat that. In order to have spin or to have a spin state, you have to have an odd number of protons and or neutrons. So, for example, H1 has how many protons? 1, exactly. And how many neutrons? 0. So if we have an odd number of protons, that checks out. So that means that H1 is NMR active because it does have a spin state. So now H2, remember, H2 is just an isotope of hydrogen. We also call that deuterium. And when we have isotopes, the number of protons never changes. We only change the number of neutrons. So we're going to add 1 neutron. So now this has an odd number of protons and neutrons. Do you guys think this is NMR active or it's not NMR active? Yes, and I 100% agree. This will be NMR active. So now let's go through the kind of more complicated ones. So tell me, how many protons are in carbon-13? 6. Cool. So that means we have 7 neutrons. We have an odd number of neutrons and an even number of protons. So what do we think? Active or not active? Yes, it is definitely active. Now for nitrogen, how many protons does nitrogen have? 7, exactly. So we know that nitrogen 14 will also have 7 neutrons and nitrogen 15 will have 8 neutrons. So between N14 and N15, which one of those will be NMR active? Yes, exactly, both. So something that people get tripped up on a lot is they look at whether this number is positive or is odd or even, and they think, okay, well, if it's even, it can't be NMR active, but that's not true because 2 odd numbers can add up to an even number. So even though this is nitrogen 14, it's made up of 2 odds, which means it is NMR active. And nitrogen 15 has an odd number of protons, so it is still NMR active. Don't get tripped up on that. I know people make that mistake all the time. So the last 2, phosphorus and fluorine. How many protons does phosphorus have? 9. And so we have 10 neutrons. Is this going to be NMR active? Yay or nay? Yes, it will be. I agree. Awesome. So now the last one. How many protons does phosphorus have? 15, so we have 16 neutrons. So is this guy NMR active? Yes, it is. It just occurred to me that I didn't include any not active examples, but essentially if we had something like carbon 12, for example, we have 6 protons, 6 neutrons, so this would not be NMR active. Any questions, comments, or concerns about this? This is a super easy concept, and he does tend to ask 1 or 2 questions like this on the exam. So if you know how to do this, that's like 1 or 2 easy points. All right, so what are the 2 most common types of NMR we use? Hint, both of them are in number 4. Yes, they are hydrogen and carbon, but it's really important to note that it's H1 and carbon 13. So awesome job, guys. And so number 6 kind of goes with that. So what solvent do we use for NMR? Someone said TSM, and that is actually the answer to a different question. We will talk about it in 1 second, but some other people, and blah, 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 excuse me, some other people said deuterated solvents. So deuterated solvents basically just mean anything that has a deuterium. So anything like CdCl3. The reason I point out that one is because that's the most common one, and that's the one he'll often use in his questions. The reason we use a deuterated solvent is because, as we see here, deuterium has a completely different NMR spectrum than H1 and carbon 13. So any deuterated solvent will not interfere with the actual NMR spectrum for hydrogen or carbon. Any questions about that? Also, someone said, I spelled that wrong to one of the answers. That's so fine. I spell like a second grader. And yes, I can repeat what I said. So for NMR, we're going to use deuterated solvents such as CdCl3. And the reason for that is deuterium has its own NMR spectrum since it's different than hydrogen 1. It's an isotope. Therefore, the solvent will not interfere with the spectrum of whatever molecule we're looking at. So we won't have any kind of interference. Everyone good? Okay, so someone mentioned this before, but the calibration standard that we use is TMS, and basically that's tetramethylsilane, and TMS is fine if you know that. And essentially, what we use TMS for is the 0 point. So it is going to be the 0 point. Now, if anyone can remind me, is 0 going to be the more shielded or the less shielded molecule? Yes, exactly. So 0 is going to be more shielded. So essentially what TMS does is that these electrons are going to be super, super, super going to the methyl side. So all the electron density will be on the methyl. So this will be super duper shielded. And in case anyone doesn't remember what the heck I'm talking about with shielded and deshielded, we will cover that in just a little bit. But I did want to bring up that word. So someone asked, why wouldn't the arrows be pointing inwards? So it's kind of beyond the scope of this class because this is an inorganic compound, but essentially silane is going to coordinate in a way that the electron density is not going to be pulled in, so it's not going to be electronegative. Therefore, the methyls can keep all of their electrons, and they're going to be super, super shielded. And that's why the arrows are going to the methyls, because instead of the electron density being pulled into the middle, it's branching out to the carbons. And then a follow-up question, would it look the same if fluorine was inside? So no, it wouldn't. And the reason for that is because fluorine is very electronegative. So if we had something like, let's just say we had that, but with fluorine in the middle, it would be stealing the electron density, so the arrows would be flipped. They would all be going into the middle. Really good question. Good? I'm going to take that as a yes, and if you have any more questions, let me know. Alrighty, so we have 4 main aspects of NMR. I know you guys covered that briefly in Orgo 1, so let's go over it together. Someone tell me one of the 4. Integration, awesome. So I have a specific order that I put them in, so don't worry if... Sorry, I can't write and talk at the same time. Okay, yes. So we have the number of signals, we have the integration, we have multiplicity. Cool. And what's another name for multiplicity? Splitting, exactly. Okay, so now we're going to go into basically what each of these things are. So the number of signals is essentially just telling us the number of unique environments. So I'm going to zoom in as I write, and then I'll zoom back out so you guys can see it. So number of unique H or C environments. The multiplicity slash splitting is going to tell us the number of unique neighbors that each signal has. And so for coupling, sorry, I was reading a question while I was talking. So we're going to talk about coupling in a second. It has to do with multiplicity and splitting, but it's not necessarily one of the 4 main aspects. So we will talk about it in a little bit. Sorry if I confused anyone because I just kind of went off the tracks. Multiplicity and splitting, though, when we're talking about the number of unique neighbors, we have a couple rules. So does anyone remember how many bond lengths? Yes, exactly. So it has to be within 3 bond lengths. Does anyone remember any other rules about splitting? They kind of gave you like an equation. Oh, okay, someone made a really good point. Yes, so something I like to call the heteroatom rule is it cannot split through a heteroatom. And I know that's one of those things where they don't really tell you what a heteroatom is. So a heteroatom is essentially anything that's not a anything that's not a carbon or a hydrogen, such as nitrogen, oxygen, sulfur, fluorine, etc. And the last thing someone mentioned is the N+1 rule. And essentially what you need to know is N equals the number of unique neighbors. We will talk more about what I mean by neighbors and what I mean by unique on the next page, but these are essentially the 3 rules that you have to keep in mind for multiplicity and splitting. So chemical shift, I'm going to move this down just a tad because I didn't give myself enough room. You will hear me say that about 2 billion times this semester because I never give myself enough room. The chemical shift is essentially telling us where something is on the spectrum. And this is in ppms. So where something is on the spectrum basically translates to how shielded it is. Last but not least, integration. So integration is essentially how many hydrogens or carbons are there per signal. This is also defined as the area under the curve, but for this class, we're not going to worry about that. So let me zoom out and show you what we've covered so far. You guys can have a chance to screenshot or write it down or whatever you would like. Does anyone have any questions, comments, or concerns about what we've covered so far?
I have a question.
Yes, what's up?
So it's more shielded if it's further to the right?
Yes, exactly. So the closer you are to 0, the more shielded it will be.
Okay, thank you. I just forgot.
You're welcome. And we're actually going to summarize today by doing a quick little NMR spectrum. Yes, the last sentence is supposed to say how many hydrogens or carbons there are. Sometimes my handwriting is not cute. Again, there you go. Ta-da! All right, so I'm going to scroll. These we are going to cover at the beginning of the next session, which is tomorrow. But I want to end today by doing a quick little NMR chart for propanol. And as we cover that, I'm going to send you guys the attendance link one more time. Pretty please fill that out. It's very important that we have like an accurate measure of who's here, who's not, when they're here, how many people are here, etc. Also, it just occurred to me that I didn't take this out from last semester. Please ignore this. I'll remove it and give you guys the actual times for your sessions. That's my bad. All right, so we have our spectrum right here. We know the x-axis is in ppms. We know that over here is 0. And depending on the carbon or the hydrogen NMR, we're going to have different values on this upper end, right? So if we're using carbon NMR, what number do we go up to-ish? About 200, yeah, 220, around there. What if we're doing a hydrogen NMR? 12, exactly. So for this one, I'm going to specify hydrogen 1 NMR. So I'm going to write 12 over here. And I'm going to go ahead and draw my buddy. Wow, that's really ugly. I'm sorry, I had to change it. My buddy propanol. So, first things first, before we get into actual propanol, let's label our spectrum. So, as I said before, wow, that's not a straight line, but I'm going to ignore it for now. So, as I said before, going more towards 0 is going to be shielded, and going more towards 12 is going to be de-shielded. And we know D and D go together, so de-shielded is down field, and shielded is going to be upfield. And a way that I've started to explain this that makes the most sense to the most people is kind of like as if we have like a little nucleus here, right? So this green dot is our molecule, and this pink area around it is the electron density, right? So this guy on the left has very little electron density, and this guy on the right has a lot of electron density. And so we can then think of these purple, or purple might be too close, so I'm going to use orange. Okay, so these arrows that I'm drawing are the magnetic field. So the less electron density you have around yourself, the less protected you are from the environment. So if we shoot something at you, like if we shoot 4 arrows at you, 3 out of the 4 are going to hit you, and 1 of them will be thrown off, right? However, if you have a lot of electron density, like this guy, if you shoot 4 arrows, 3 of them are going to bounce off, and only 1 is going to go inside. So the more shielded you are, you have more electron density, and you are less affected by the surroundings. And the less affected you are, the smaller number you'll have on the graph. However, if you are less shielded, you have less electron density, you are feeling more attacks from your environment, so you are going to have a higher number on the spectrum. Does this analogy sort of kind of make sense? Yes, no, maybe so. Yes?
Yeah,
okay.
it does.
Cool, awesome. So this is approximately where I wanted to finish off with you guys today. It was kind of a slow day. We didn't go over too much because I wanted to kind of dip your foot into it and give you an idea of what SI is and whatnot. We're going to start going a little bit faster starting next time. But again, you will still be able to ask questions. We're going to do a bunch of practice problems, all that kind of stuff. Yes, I saw that someone is asking a question. I will answer in 2 seconds. I just wanted to say it is technically time. So if you are good, you don't have any questions or anything, you are free to go. Thank you for coming, and I will see you next time. But I will be staying a couple minutes to answer some of the questions that people had. So have a great day. And yes, I will scroll up so you guys can see everything. Ta-da. Okay. So, to the people, so someone said, it keeps pulling me down. Yes, so I will repeat everything I said one more time. And okay, so someone asked, does that mean it will have more spin? And so, no, a spin is going to be different. Spin is basically just telling us that it's going to work in the NMR. So spin isn't like, think of it as a yes or no, not like how much spin there is. So either you have it or you don't. And if you have it, awesome. If not, you can't change that. So you're not going to have more or less spin, any of that kind of stuff. What we're talking about over here is the amount of electron density you have. So for example, if we have an OH bond, right? We know that the oxygen is way more electronegative than the hydrogen. So let's pretend this doesn't even exist, right? So we're going to have a lot of electron density here and only a little bit here. Because the oxygen is so electronegative, it's stealing all the electrons. So if we're comparing that to this model, right, this oxygen will be super shielded, whereas this hydrogen will be super deshielded because all the electron density is gone. So that's more so how you think about it. Does that make a little bit more sense? Okay, awesome. You're very welcome. And so, yes, carbon NMR will essentially be 10 to 220. And hydrogen NMR is going to be 0 to 12. Yeah. Anything besides the carbon and so think oxygen, nitrogen, sulfur, fluorine, all that kind of stuff. You are very welcome. Okay. Any more questions? You guys are asking such wonderful questions, and I love how much you're participating. You guys are awesome. I'll stay for like one more minute in case anyone has any other questions. But I hope you guys have a wonderful day.